All right, let's cut right through the massive hype surrounding AI today. Welcome to this explainer where we're looking at agentic AI, why 95% fail, and who's quietly winning. You know, everybody right now is obsessing over GPUs, compute power, and these massive flashy server farms. But today, we're going to look at the sober, fact-based reality of what is actually working in the enterprise. And more importantly, we're going to uncover who the real underrated winners are. Because while this gold rush is happening right on the surface, the companies making the most vital picks and shovels, they're quietly sitting on a completely different layer of the tech stack.
Here is our roadmap for this explainer. We're going to look at 1, the reality of agents; 2, the hardware causal chain; 3, the secret SSD boom; 4, why this boom lasts; and finally, 5, the next AI wave. Okay, section 1, the reality of agents, handcrafting over hype. Before we even touch the hardware, we really need to understand what this software is fundamentally doing and why it is so insanely resource intensive. Think about it like this. A chatbot just gives you the bank's phone number, right? But an AI agent, it's already called the bank for you. A standard chatbot is just a simple loop. You ask a question, you get an answer. You are basically the human in the loop. An agent, on the other hand, is given a broad goal. It creates a plan, it executes the steps, it checks its own results, and loops back. The model itself is in the loop, acting autonomously and triggering anywhere from 10 to 50 separate tool calls in a single turn. It's a complete paradigm shift. Agents are autonomously stringing together external tools, checking their own short-term memory, and running complex loops to actually execute tasks. They're reading databases and running code on the fly. But here is where we need a harsh reality check. Making this actually work in a real business environment is incredibly tough. Let's look at the hard numbers from a 2025 MIT NANDA study. Roughly 95% of enterprise AI initiatives just fail to deliver any measurable return. Why? Mostly because of crappy, unstructured data and overly broad project scopes. But, and this is a big but, the 5% that do actually succeed, they pull massive value. We're seeing aggregated vendor-reported figures of around 171% to 210% ROI, making those tasks roughly 9 times cheaper than human work. It works beautifully in narrow, high-volume areas. Take IT Help Desk, for example. Some vendors are reporting up to 88% of tickets resolved in under a minute. But here is the ultimate punchline for our story today. Even the 95% of failed pilots are burning massive amounts of compute and storage. So the failure rate doesn't actually stop infrastructure demand. It actively drives it as companies just keep experimenting.
Which brings us to section 2, the hardware causal chain, the hidden pull. Now, we all know NVIDIA and SK Hynix are absolutely crushing the GPU and memory race. I mean, look at this. SK Hynix is sitting on a mind-blowing 72% operating margin for Q1 2026. That is literally higher than NVIDIA and TSMC. Everyone knows this part of the story. High bandwidth memory, or HBM, is effectively sold out for the next 3 years. But why is the strain so intense? Well, look at the sheer math here. Upgrading from a standard chatbot to a complex, deep research agent multiplies the memory bandwidth load by up to 2,000 times. Agents are memory-bound, not compute-bound. Every single time that agent thinks or uses a tool, it generates massive amounts of internal tokens, requiring incredibly long contexts just to remember what it did a second ago. So let's trace this causal chain because it forces a massive industry-wide pivot. More agents and longer contexts drastically drive up the need for HBM. But HBM is just way too expensive and way too scarce to hold all that temporary memory, specifically what's called the KV cache. You can't just put everything there. So the system has to offload that data. Where does it go? Well, it branches off to the CPU to orchestrate all those constant tool calls, pushing the CPU to GPU ratio from 1 to 8 way closer to 1 to 1. And crucially, that massive memory load gets dumped straight onto cheaper, high-capacity solid-state drives. Bottom line, if you say HBM, you literally have to say SSD and CPU too. And that takes us directly into section 3, the secret SSD boom, the underrated layer. While everyone is staring at the shiny, expensive HBM attached to the GPU, the cold storage layer down at the bottom of the stack is experiencing the most violent price movement of the entire memory market. Check out this illustrative number from the vTrueDie Index. A single 30 terabyte enterprise SSD rocketed from about $3,000 to $17,500. That is a 472% price spike. Now, to be totally transparent, that specific index gets sharply revised, but the core direction of this explosive growth, that is absolutely backed by hard TrendForce contract data. For the first time in this cycle, NAND memory prices are actually rising faster than DRAM. And because traditional hard drives are just too slow and have massive lead times, data centers are desperately buying up enterprise SSDs for vector storage, inference caching, and model checkpoints. The result? The entire enterprise SSD industry is totally sold out for 2026. SK Hynix, Samsung, Micron completely tapped out. Micron actually reported their NAND revenue was up 169% year over year, explicitly saying that demand is massively outstripping supply. AI servers are just vacuuming up every single drive these companies can possibly manufacture. Moving on to Section 4, why this boom lasts. Structural, not cyclical. Now, you're probably thinking, okay, the memory market is notoriously cyclical. This is just another hardware boom-bust bubble, right? Well, not exactly. Look at NVIDIA's ICMS. That's Inference Context Memory Storage. They are physically baking this KV cache offloading directly into their architecture. This means high-capacity NAND isn't just a one-time expense for training a model anymore. It is now a permanent, recurring requirement for AI inference. Forward estimates from Citi actually suggest this single feature will drive NAND from taking up about 2.8% of global demand in 2026 to over 9% by 2027. It anchors SSD demand into the very heart of the AI process.
And this totally breaks the old 2018 boom-bust dynamic. Back then, memory was bought on the spot market, which led to wild price crashes when demand dropped. Today, hyperscalers like AWS and Google are quietly signing long-term agreements, locking in SSD supply well into 2028 and 2029. Think about that for a second. When the biggest cloud providers in the world legally commit to buying your entire supply for the next 3 to 5 years, you aren't looking at a cyclical hardware story anymore. You're looking at a structural reality. Sure, cycle risk always exists, but right now, this supply is locked down tight.
Which brings us to our final part, Section 5, the next AI wave. Physical AI. Because, you see, the demand doesn't just stop at software agents. We're really only in the middle stage right now. We moved from standard chatbots in 2023 to the complex AI agents we're building today. But by 2027, as this hardware scarcity continues, because it takes years to build new fabrication plants, we're going to hit the next massive wave, physical AI. We're talking robotics and autonomous systems that have to constantly perceive, reason, and act in the physical world. That is going to put a simultaneous crushing demand on all memory classes at once, while completely stressing our energy grids. So, I want to leave you with this provocative thought to ponder. If you are a standard enterprise, just trying to upgrade your regular IT servers, but AWS, Azure, and Google have already contractually bought every single enterprise SSD coming off the production line through 2028, what exactly is your next move? This AI boom isn't just minting new winners. It is actively starving the rest of the tech stack of its basic building blocks. Keep an eye on that hidden, sold-out SSD layer, because understanding that is how you truly understand where the value is flowing in this AI revolution.